Assalamualaikum warahmatullahi wabarakatuh. In this lesson, we are going to relate light rays and wavefronts. Okay, so before we start with that, let us look to the word of optics. So in physics, we have many field. We have mechanics, thermodynamics, heat, so many of them, and one of it is optics. So what is optics? Optics is the study of light. In Malay, cahaya. In Chinese, Huang, I think. Japanese, hikari. In Arabic, is nur. So it's a study of light. Okay, so can you see light? Can you see light? If you can see light, can you draw light? So it's difficult to answer that question, right? We see light, but we cannot draw light. So, for example, we have a bulb, and you see the bulb is bright. So, how can you draw lights from the bulbs? So that is problem in if we want to study light, but we do not know how to draw light. Okay, so in optics we have three subfield of optics. The first is geometry optics. Second, physical optics, and third is quantum optics. Okay, so for geometry optics, we represent light as a ray. Okay, ray. Light as a ray. So what is ray? Ray is one straight line like this, and it has an arrow. So this is called ray. So this ray represents light. So light coming from this bulb will go in many directions. So we can represent light. We can model the light as a ray. So this is called ray, one straight line with an arrow, representing the direction of light propagation. Alright, so this is ray. So in geometry optics, we use the concept of ray to represent light. So this is useful to explain the phenomena of light reflection and also light refraction. Okay, in the next step, there are some phenomena that we cannot use ray. We need to use alternative representation of light. So those phenomena such as diffraction and dispersion, we cannot use ray. We need another concept of light. So in physical optics, we represent light as wave. Okay, so you can have wave. We learn that wave, it has a wavelength, right? It has wavelength, it has peak, and it's true. So we can represent light as a wave propagating in all direction. So this is called wave representation of light. So when we use wave representation of light, we call this kind of this field of study as a physical optics. So physical optics use wave to represent light. Alright. So further, we can also represent the light as a wavefront. So what is wavefront? Okay, so if you read from the worksheet, a wavefront is a line of all points of the same vibration or oscillation phase. Alright, so if you look here, this is the peak of wave. This is a peak of wave, and you have, so you have this, so you have peak of wave, you have peak of wave. So when you connect these peaks from the wave, so this is called wavefront. So this is wavefront. So you can have one wavefront, you can have another wavefront. So this means we have many wavefront as the light progress. So also the wavefront also move with the progression of the light. Okay, so this means this is the representation of wave. So this means without this. So this is wave and wavefront. Okay, so the distance between wavefront is lambda. Alright, so both of these representation of light is treated under physical optics, and this this wave and wavefront can explain the phenomena of diffraction and dispersion. All right. So, what is the relation between ray, wave, and wavefront? Okay. So, if you have light here, this is your light, corresponds sun, and you can represent light from the sun as a ray. So, this is your ray. So, it is directed in all direction, straight line, and representing the propagation of wave. So, from ray, you cannot use wavelengths because you cannot see where is the wavelength of the wave. So we need advanced representation of light using wave. So wave, you have this red color. So this is wave, and it has specific wavelength. It has amplitude, right? So this ray, when we use wave, we use this representation with this drawing to represent light. And wavefront is when you have this wave and you have many waves. So when you connect all peaks of the wave, when you connect them, so you have this as wavefront. Okay, so this yellow line is wavefront, this is wave, and this is ray. Okay, so wavefront and ray is 90 degrees to each other. So wavefront and ray, they are all perpendicular to each other, perpendicular. So when we have to use ray, when we have to use wave, when we have to use wavefront, depend on situation. So for example, reflection and refraction, when you want to describe reflection and refraction phenomena, you have to use ray. When you want to explain diffraction and dispersion phenomena, you can use wave and wavefront. Alright, so the third category, which is a higher level in optics, is called quantum optics. So in quantum optics, light is represented as a particle, one small discrete of energy, which is coming from bulb. So we can imagine that the light is like a particle going out, a stream of particles. We call it as photon. So this representation can explain the phenomena of photoelectric. Alright, so in this course, we only consider geometry optics and physical optics. So quantum optics will be, in another course. So we are not considering this. But this is 3 different subfield of optics. This to let you know that sometimes we use ray representation, sometimes we use wave and wavefront, sometimes we use photon to represent light. So when we can represent them, so we can understand them better. So it's like a electron. So have you seen electron? We cannot see electron. And usually when we study about electron, we represent electron as a ball, even though it is not a ball. So in science, usually we make a representation of something to make it abstracting more visual and more understandable for us to study. All right.